Good morning, dear students. Today we are going to start with the last two topic of chapter 1, some basic concepts of chemistry. So today we will see stoichiometry and the calculation based on stoichiometry. Along with this, we will also discuss about limiting reagent. So let's start. One of the most important aspects of a chemical equation is that when it is written in the balanced form, it gives quantitative relationship between the various reactant and products in terms of moles, masses, molecules and volumes. This is called stoichiometry. In Greek, stoichiometry means measure of an element. So, the coefficient of the balanced chemical equation are called stoichiometric coefficient. For example, if I say the reaction C plus O2 gives CO2. This is a balanced chemical equation. Along with the quantitative information conveyed by it, it gives the relation of moles, it gives the relation of grams. So, chemically we say the quantitative information conveyed by a chemical equation help in a number of calculation. The problems involving these calculation can be classified as mass-mass relationship, mass to volume relationship, volume to volume relationship. So let's see how to start with the stoichiometric calculations. Here you can see a question. Find the mass of CO2 produced when 16 gram of methane is burned. For this, you have to write the reaction. CH4 plus O2 gives CO2 plus H2O. Methane CH4 burned in air O2. Whenever oxidation takes place, or you can say combustion takes place, it gives carbon dioxide and water. So first of all we will balance it. So when you will balance it, it will be CH4 2O2 CO2 to H2O. From this equation, which information we are getting? 1 mole of methane when react with 2 mole of O2, we get 1 mole of CO2 and 2 mole of water. In grams, calculate the mass of CH4. 16 gram of methane when react with mass of oxygen is 16. 16 into 2, 32 into 2. 64 gram of oxygen. It gives 44 gram of CO2 plus 36 gram of water. So these two information we are getting from the balanced chemical equation, right? Now, in question they are asking when 16 gram of methane burn. So here you can see when 16 gram of methane burn, then how much CO2 produce? So directly you can see with 16 gram of methane, 44 gram of carbon dioxide will be produced. Now, in second part, when 2 gram of methane is burned. So, from here only you can get the relation. If 16 gram gives 44 gram of CO2, then 2 gram will give how much? So, 44 upon 16 multiply by 2. 2, 8, 22, 11 by 2. In the same way, you will calculate the next part. In the next part, third question, when 2 moles of methane burn, then how much CO2 produced? So when 2 mole of methane burn, here you can see when 1 mole is there, then 44 gram. For 1 mole, 44 grams CO2 produced. Why we are writing grams? Because mass of CO2 they are asking. So 1 mole gives 44 grams. So 2 mole will give 2 into 44. That is 88 gram. Right? And in third, for last one, 0.5 mole. So instead of 2 mole, now they are asking for the 0.5 mole. So this relation you are knowing from the equation. 1 mole gives 44 grams CO2. 0.5 mole gives 44 divided by 0.5. That is 22 gram. Right? So in this way, try to calculate. Next question, calculate the amount of water produced by the combustion of 16 gram of methane. Now same equation is there. CH4 plus 2O2 gives CO2 plus 2H2O. Now in this, when you will write in mole, 1 mole, 2 mole gives 1 mole plus 2 mole from the equation. 16 gram CH4, then O2 16 mass, 16 into 2, multiply by 2, that is 64 gram. Again carbon dioxide 44 gram and water 36 gram. Now what they are asking? They are asking when 16 gram of methane burn. So when 16 gram of methane burn, what will be the amount of water now? It's 36 gram. Second part, 2 gram of methane. When 2 gram of methane burn, then how much water? 36 upon 16 multiplied by 2. Calculate, you will get the answer. In third part, 2 mole of methane. So same way, right now we have calculated. If 1 mole gives 36 gram, then 2 mole gives 36 multiplied by 2. Calculate and find the answer. Now, if 0.5 mole is there, 1 mole produces 36 gram. So 0.5 mole, 36 divided by 2 or multiply by 5. Any you can do. Calculate, find the answer. Now these two questions are your homework. How many moles of methane are required to produce 22 gram of CO2 after combustion? Same equation you have to use. And next question is, calculate the mass of iron which will be converted to its oxide Fe3O4 by the action of 18 gram of steam on it. This is the NCERT question. Try to solve it. Now again, very most important question of NCERT. What mass of slaked lime would be required to decompose completely 4 gram of ammonium chloride NH4Cl, and what would be the mass of each product? So first of all, balance the equation. When you will balance the equation, you will get CaOH whole twice, 2NH4Cl, CaCl2, 2NH3, 2H2O. This is the balanced equation. Now what information you are getting? Moles, 1 mole, 2 mole, 1 mole, 2 mole, 2 mole. In grams, calculate the mass of CaOH whole twice. 74 gram, 107 gram, 111, 34, 36. Right? Now in question, what mass of slaked lime? Slaked lime is CaOH whole twice. To decompose completely, 4 gram of ammonium chloride. Here you can see if 74 grams slaked lime required 107 gram of ammonium chloride. So for 4 gram it will be 107 upon 74 multiplied by 4. Solve it. You will get 2.76 gram. So 2.76 gram, this mass of slaked lime required for the decomposition of 4 gram of ammonium chloride. Now here you have to calculate the mass of all three products, CaCl2, NH3 and H2O. So what we will do for all the three? In order to calculate the masses of all the three, the same process you have to follow. For example, in case of CaCl2, 111 gram of CaCl2 obtained from 107. So, for 4 gram of NaCl, it will be 101 upon 107 multiplied by 4. You will get 4.15 gram. Next, in the same way, for calculation of ammonia. So, 107 gram NH4Cl gives 34 gram of Ca 34 gram of ammonia. So for 4 gram it will be 34 upon 107 multiplied by 4. You will get 1.271 gram. Similarly for water, 107 gram CaOH gives 36 gram of water. So 4 gram gives 36 upon 107 multiplied by 4. You will get 1.34 gram of water formed. So in this way, try to solve all the questions related with the stoichiometry. The method right now we are using is known as unitary method. So we are applying the unitary method for the calculation of stoichiometric problem. Now the last topic is the limiting reagent or the limiting reactant. Quite often, one of the reactant is present in larger amount in the reaction than the other as required according to the balanced equation. The amount of the product formed depend upon the reactant which has reacted completely. This reactant which reacts completely in the reaction is called limiting reagent or limiting reactant, and the reactant which is not consumed completely in the reaction is called excess reactant, as the excess of this reactant is left unreacted. So, in short, we can say the reactant which react completely in the reaction is called limiting reagent or limiting reactant, while the reactant which is not consumed completely in the reaction is called excess reactant, as excess reactant is left unreacted. For example, A plus B gives C. In this equation, balanced equation, 1 mole of A react with 1 mole of B to form 1 mole of C. Right? Now, if I will provide you 2 moles of A, right, and 1 moles of B, then how much C will be produced? So from the balanced equation, you know that they should be in the same ratio. So you are having 2 moles of A, but you cannot add all the A molecules, because for adding 2 moles of A, you should need 2 mole of B also, but you are not having. So what to do? You are not having any option. You will add 1 mole of B and 1 mole of A. So you will get 1 mole of C. In this condition, your B will finish because you have added all B molecules. But 1 mole of A, after adding, you are having left over 1 mole of A also. So 1 mole of A is left unreacted, that is the excess. And the reactant B, which is not now left, it reacted completely in the reaction, known as limiting reagent. So we will see few questions related with this. For example, calculate the amount of carbon dioxide produced when 1 mole of carbon is burnt in air, 1 mole of carbon burned in 16 gram of dioxygen, and 2 mole of carbon burned in 16 gram of dioxygen. So here you will write the reaction first. C plus O2 gives CO2. What information you are getting? 1 mole, 1 mole, 1 mole. In grams, 12 gram, 32 gram, 44 gram, right? Now they are asking calculate the amount of CO2. Amount you have to calculate means in gram. When 1 mole of carbon. So here you can see when 1 mole of carbon burned, then how much CO2 produced? 44 gram. So 1 mole of carbon gives 44 gram of CO2. In second, if 1 mole of carbon is burned in 16 gram of dioxygen, here they are decreasing the oxygen content. Carbon is 1 mole only, but instead of 32 gram, now 16 gram is there. 16 gram means 0.5 mole. So as I have given you the example, now your O2 is less and carbon is more. So for this you need 1:1. So you will take 0.5 and 0.5. So you will get half mole of CO2 means 22 gram. So with 16 gram of oxygen, you will get 22 gram of CO2, and the carbon will left over, that is the excess. O2 is the limiting reagent. Now when 2 mole of carbon is burned in 16 gram of dioxygen, they are increasing this carbon only. 2 mole of carbon they are increasing. So again there is no use of increasing the carbon. Carbon will be reacted with 0.5, 1 mole, or the respect ratio will be 1:1. So in this condition also, if the oxygen is 16 gram, that is 0.5 mole, the reaction will be in the 0.5 mole ratio only. So again you will get 22 gram of the CO2. Try to solve these questions of stoichiometry. What will be the mass of 1 carbon 12 atom? Calculate the number of atom which is related with the mole, and 50 kg of N2 plus 10 kg of H2 are mixed to produce ammonia. Calculate the ammonia formed. So here you will write the reaction N2 plus H2 gives NH3. Balance it. So now you will start with this reaction. Identify the limiting reagent and in the production of ammonia. Try to solve these three questions. Now, a very important question by which you can clear your concept of limiting reagent is question number 4. In the reaction, A plus B2 gives AB2. A is atom and B2 means that is the molecule. So you have to identify the limiting reagent in every case. First of all, when 300 atom of A and 200 molecule of B, ratio is 300 molecule and 200. So from the balanced equation you can see, is it possible to react in the ratio of 3:2? No. Their ratio should be same. Atoms A and molecules B2, they should react in the ratio of 1:1. Here they are giving 3:2. So you can react it in the ratio of 2:2. In doing so, your A will be left over. So if A will be left unreactant, so what will be the limiting reagent? In first case, B will be the limiting reagent which will be used completely. Second case, 2 mole of A and 3 mole of B. Here you can see the reverse condition. 2 mole and 3 mole. As I told you, the ratio will be according to the smaller one. So ratio can be 2:2. Which will be left over? According to the reaction, B will left over because it is more. So what will be the limiting reagent? In this case, 2 mole of A means A will be the limiting reagent. Third case, 100 atom of A and 100 molecules of B means their ratio are same. So according to the equation also, they should be in the ratio of 1:1. So it will not have any limiting reagent because both will react completely. Fourth case, 5 mole of A and 2.5 mole of B. 5 and 2.5. So ratio can be equal. Here if you will have this ratio, it is clear that 5 is more. It is excess. So B will be the limiting reagent, and in the last one reverse condition, so A will be the limiting reagent. So whatever the quantity is less is the limiting reagent, which is in excess is the excess reagent. Thank you. God bless you. I hope these topics are clear to you. Try to solve the NCERT and complete the NCERT in text and back exercise.